Good evening everyone. I am Rachana. I am from ISC department 6th semester. I am here by to explain you about how the buddy bucket algorithm works. Before going to the topic, we shall know what you mean by bucket. Buckets in the sense which stores more than one record per address. Record in the sense collection of fields, probably it is a data like structure. So, bucket means an area of a hash table with a single hash address as room for more than one record. For this, let's consider one hash table with a single hash address. That room will be surrounded by only more than one record. That is what bucket. Hope you got it. When using buckets, an entire bucket is read or written as a single unit. It means that probably your whole bucket will be read or written as a single unit that consists of the buckets. And there is an important note, just note it. Records are not read individually. Yeah, of course, records will be not read individually. Why? Because here is the reason. When processing large amounts of data, it's often easier to group information together instead of dealing with the lots of individual variables. As you know, instead of dealing with the individual variables, if we group the same information together, the large amount of data will be easy to access. So, records are not read individually. It will be accessed in a group. And there is application of bucket in the below line. The use of buckets will reduce the average number of probes required to find a record. As you know, the bucket will be used to reduces the average number of probes required to find a record. Hope you got it, people. Here is a simple example. Let's consider the address, counters and the records. Address is what we store the counters and the records, where it will be stored, and usually the counters will be helped to keep track of the how many records are already stored in the given address. It means that counters helps us to keep track of how many records are already stored in the given address, which are already stored in the given address. Here is the use of the counter. Here it will be applicable. And records. Records actually in above figure, as I am showing you now, it represents a storage record with a size bucket size of the 3. It shows the bucket size will be equal to 3. Next, let's move on to the main topic. It's called a procedure for finding the buddy buckets. It's so easy, friends. The method works by checking to see whether it is possible there to be a buddy bucket. Why this buddy bucket algorithm is used in the sense whether to check the condition whether it is possible to be a buddy bucket or not. Clearly, if the directory depth is equal to 0, it means that there is only single bucket available. There cannot be a buddy. If suppose the directory depth is equal to 0, it concludes that there will be a single bucket and that cannot be a buddy. And as we follow next, the next test compares the number of bits used in the directory address space. And the next comes, as you know, next case will be like comparing the number of bits in the directory address space, where the counter and the records and the address are stored in that hash table. This process will be carry on. A pair of buddy bucket is a set of buckets that are immediate descendants of the same node in the tree. Tree in the sense, it's like a tree-like data structure whose nodes store the letter of the alphabets. Here, it concludes that a pair of buddy in the sense, a pair of buddy like two pairs, two buckets will make one buddy, and it's a set of buckets that are immediate descendants of the same node in the tree. As I told, tree is like a tree-like data structure whose node stores the letters of an alphabet. It is only when a bucket is at the outer edge of the tree that it can have a single parent and a single buddy. When can be a single parent and a single buddy in the sense when it is only at the edge or outer edge of the trie, then it appears a single parent and a single buddy. Let's go to the next one. Once we determine that there is a buddy bucket, we need to find the address. So when we are confirmed that there is a buddy bucket, we need to find the address of the particular buddy bucket. For this, we need to go to the algorithm below as I mentioned there. Int bucket, scope of resolution, and the find buddy. It means that find the bucket that is paired with this. Like we have to find the buddy bucket, whether it is paired or not. Like it is, we have to find the buddy bucket. That is the meaning of that line. Next, open the bracket. If directory depth double equals 0, then return -1. It means that directory depth is double equal to 0, then we have to return to the -1 step. So it includes it tells that no buddy and empty directory unless there is a no buddy found, so that empty directory will be like that until and unless the bucket depth and the directory depth there is no single bucket to pair with. It means that the empty directory unless and until it occurs, that bucket depth and the directory depth will be double equals. Next we shall go to next step. If depth less than directory depth, then return -1. This condition will be satisfied and it will tell that when none is found. It means when no bucket or a no buddy bucket is found, the condition will be satisfied. That condition in the sense depth less than the directory depth. As we find such pair, we know that we can't collapse a directory and the method returns. That is the meaning of the return -1. So depth less than directory depth, then we will return to the -1 stage. It means that as we find such pair like return depth less than directory minus depth, if we find that condition, we will come to know that we can't collapse a directory and such method returns. We can't find a directory and the method will return as the same, like return -1. Okay, we shall move on to next one. The collapsing operation consisting of allocating space for a new array of a bucket address. That is in the sense half the size of the original and copies the bucket references shared by each cell pair to a single cell in the new directory. It means that the collapsing operation, as I told you before in the before part, there will be no bucket found. So what will be there? The collapsing of the directory will be found and it will return to the -1 stage. And the same explanation continues here. The collapsing operation consists of allocating space for a new array of bucket address that is half the size of the original. That will be the half the size of the original bucket. And then it copies the bucket that bucket reference shared by the each cell pair to a single cell in the new directory. Pair in the sense buddy bucket paired to a single cell in the directory it will share. Hope you got it, friends. Next, int shared address equals make address. Keys of 0, depth. It tells that the address of any key, like it will show the address of any particular key that we have to find. And return shared address power 1. It means that the exclusive or a low bit or with a low bit. Since we know that the buddy that was formed from a split, like as we know the buddies are formed by splitting each other, we know that the buddy has the same address in all regards except for the last bit. Yeah, from starting till the last, before the last bit till before the last bit, the address will be same and the same address will follow until the last step. But in the last step, last bit, it will change. Like the buddy address will be flipped last bit with an exclusive OR. That will be the last bit will be replaced by the exclusive OR bit, so that it concludes the first from the starting to the last before stage, the same address will be followed, but at the last stage the last bit will be flipped with the or swapped with the exclusive OR bit. This is what how the buddy bucket algorithm works. Hope you got it, friends, and thank you.